only it can be accessed by the processor. Okay, so for that all the 2 cache memory blocks are already filled, right? So we need to replace one of these 2 cache blocks, right? And we need to bring it this required cache block, that is the data needed cache block, right? So for that what we need to do is we have to swap out, or called as eviction, right? So this cache memory block 2 needs to be evicted out, right? Because it is the least recently used. So when you compare these 2 blocks in the question itself, it might be given that out of the cache blocks, which one is least recently used, right? Least recently used cache block, right, has to be evicted out. So this block 2 is the least recently used. That means it has been used in a very longer time, right, longer time back. So this block 2 has to be evicted out, and this particular block, that is the data needed block, has to be brought in, right? This is what we call it as least recently used cache replacement strategy. Please make a note of this: least recently used cache replacement strategy. Okay. Still many students didn't join. Okay. I'm sure I will take this attendance. Regular class also RSA is late comer. Now also he is putting attendance now. So cache memory block size consideration, right? So this is an important point for a part A question. Larger blocks should reduce the miss rate. So larger the cache block size, that will ultimately reduce the cache miss rate due to the spatial locality. But there are 2 cache designs. One is fixed size cache, another one is variable size cache, right? So in a fixed size cache, larger the back blocks, then there will be only very fewer cache blocks, right? There will be more competition among which main memory block can be placed in the cache memory block. So the contention for placing a particular main memory block in the cache will be very high when we design a cache with a larger block size. So and the larger blocks will also pollute the environment. That means there will be frequent swap in, swap out, right? So when we can go for larger block sizes, when we want to access a item which is located in the very nearby indexes. The very nearby indexes, we can go for these larger cache blocks. So when a CPU requests a particular data item, if it is present in the cache, we call it as cache hit. If it is not available in the cache, then we call it as cache miss. So what are the steps we need to do when a cache miss occurs? Need to stall the CPU pipeline, fetch the block from the next level of memory, right? That is fetch the particular block from the next level, that means the main memory. And instruction cache, there are two types of cache misses. Again, instruction cache miss and data cache miss. Instruction cache miss means the particular instruction is not available in the cache memory, so we need to restart the instruction fetch stage of the pipeline. Suppose if a particular data item is not available in the cache, then we call it as data cache miss. So we need to wait and stall the pipeline and complete the data access. So that is the only possibility if catch miss happens. And when we have multiple copies of data in the cache memory as well as in the main memory as well as in the hard disk, right? So when the processor updates a data in the cache memory, it has to be updated in main memory also, right? The CPU is responsible for updating the data which is modified in the cache to the main memory, right? So how it does? There are three techniques for cache updation. So far we have discussed about cache mapping, and then cache updation, then cache replacement, right? So cache updation in the sense that when your data write hit, that means the requested data is available in the cache memory and it is being modified by the processor. Processor has modified that data item, and that modification needs to be incorporated in the main memory block also. That means write through is one of the schema in which once the data is modified in the cache, immediately that particular data item will also gets updated in the main memory. Write through, right? Whatever modification which is happening in the cache, that has to be reflected immediately in the main memory. So for that, additional clock cycles are required. So if the base cycles per instruction, CPI is cycles per instruction is 1, then that is 10% of the instructions are stores and writes to the main memory, right? And it takes 100 clock cycles, then the effective CPI will get increased to 11. 1 from 1 to 11 it will get increased cycles per instruction, right? So this write through is a very costly cache updation strategy. So we go for a solution called write buffer. That means we need to hold the data item which is to be written in the memory in a buffer space, right? When there are some stalls occurs, or when the CPU wants to write a large volume of data from the cache to the main memory, we can update this cache buffer. And then write back, right? This is one more strategy for cache updation. When a data write hit happens, we need to update that particular block in the cache. No need to update the main memory. So we need to keep track of how many cache blocks has been modified by a bit called 30 bit in the cache. So this 30 bit is used to keep track of whether the particular cache block is modified or not modified. Suppose when the write through happens, which are all the blocks in the cache memory that are dirty, which will be transferred to the main memory. Write allocation, right? What should happen on a write miss, right? So that means this is the third alternative for write through and write back. So when a write miss happens, we have to allocate that particular cache block on the miss. And write around is another technique where we don't need to fetch the blocks. So, and a summary of the cache placement strategies that we have discussed so far. So the same example, the total of 32 main memory blocks. And there are three different placement schemas: direct mapped, set associative, and fully associative. Direct mapped we have discussed in elaborately. Right? We have to see about the set associative memory block. So set associative in the sense that suppose you can see now we want to place this 12th main memory block, right? But in case of direct mapped cache, 12 mod 8. 8 is the total number of blocks in the cache. 12 mod 8. So we will get 4, right? So the fourth block, this 12th block will be placed. So 12th block of main memory will be placed in the fourth block. But in case of set associative, so your cache memory is splitted into sets, right? So each set can have 2 or 3, 4, that depends on the design, right? So in this example, each set have 2 cache memory blocks. Then we call it as two-way set associative. Two-way set associative. Suppose if there are 4 contiguous cache memory blocks are recognized as one set, then it is 4-way set associative cache mapping, right? So this is an example for two-way set associative. So now we want to decide upon in which cache block the 12th block of main memory can be placed, and the formula for it is, so the main memory block number mod number of sets. Mod means modulo. That is the main memory block modulo number of sets in the cache. So in this case there are 4 sets, because 2 contiguous cache blocks forms one set. Right? So 12 mod 4. 12 mod 4. So this is how we define this set associative cache memory. So again there are few examples for you to better understand. Right. Right. So how can you find out a particular word in a set associative cache? Right. So let us see, your memory address is of 32 words byte address, right? So and you can notice that 5-bit tag that has to be searched, right? And the byte offset within the block. Right? Say for example, each cache block will have 2 bytes. Right? So this B0 and B1 is used to select which byte is to be selected within the particular cache block. And this valid bit and the tag bit that encompasses whether it is a hit or miss. Right? Since there is no index, right? No index for this, so this address, 32-bit address, that has to be compared with all the tags. That has to be compared with all the tags in the cache block. Okay? So that is one disadvantage of associative cache, set associative cache, right? Any doubt up to this point?
No, sir.
Any students still coming late, they won't get attendance. Okay. So is this particular slide visible?